Okay, so now let's say we want to have a look at the graph of y is equal to x squared. Okay, so the first thing we want to do is we want to sketch it. Now try to sketch this as accurately as you can. Do it on a sketch paper if you can. Okay, graph paper. But here I'm just going to draw it like that. Okay, so this is y is equal to x squared. So I'm going to put some points in this. So I know that if I'm at 1, then this is going to be at 1. If I'm here at 2, then this is going to be hit at 4, and so on. Okay, and then here I have -1, this point, and here I have -2. Okay, and then this has 0. Okay, what I want to do is I want to draw tangents to this curve at each of these points. That's first tangent. We have next tangent. Here we have one tangent, then another tangent. Okay. Now what you want to do is find the gradient of each of these tangents. So this tangent, what you need to do is you need to find out what's the rise over run, and then here again, what's the rise over run. Sorry, that's the run, and that's the rise, and so on. So if you've drawn this on an actual graph paper, you can simply measure what that is with a ruler, and then measure what that is with a ruler, and divide these two numbers by each other. Okay, so if you do this accurately, here you should basically just get, so at that point, at point of x is equal to 2, your m should be 4, and at point of x is equal to 1, your gradient should be 2, and then here your gradient should be -4, and here it should be -2, and here obviously it's going to be 0 because it's a straight line if you draw the gradient. Okay, so if I write this down, I said at x is equal to 1, our gradient was, what was it? It was 2. At x is equal to 2, our gradient was 4. At x is equal to 0, our gradient is obviously 0. At x is equal to -1, our gradient is -2. And at x is equal to -2, our gradient is -4. Okay? So what we want to do now is we want to draw a graph of this gradient. How do we do that? So you draw a graph, you draw the axis, so the x-axis and the y-axis. So your x-axis here will basically represent still your x, but your y-axis represents your m, or your gradient. So this is your independent axis, so this is your independent variable, and the other one is your dependent variable. Which makes sense because if you think about it, the value of the gradient depends on the value of x, right? So according to what value of x you choose, your gradient is changing, and that's why it's a dependent. Okay, so if I'm graphing that, then at x is equal to 1, right? I have said that my m is 2. I can just go there, and this is my point. Okay, at x is equal to 2, my m is 4. At x is equal to 0, my m is 0. At x is equal to -1, my m is -2. So I'm at that point, and at x is equal to -2, I'm there. So now that I have all these points, I can just connect these. Well, these really should go through those points. Sorry. Okay, so now we've got a line that's going through all of those points, and you can see that it's a straight line, and you know that its gradient is basically constant. Okay, so this is the graph of the gradient of this curve. So a couple of things now you need to point out. You can see here we had an x is equal to 0, which is there, Now at x is equal to 0, you knew that your gradient is 0. And that's why here you have a 0. Now on this side, you can see that your curve is increasing, so that means that your gradient was positive. And that's why your gradient here. So when it's positive, what it means in your gradient graph, what that means is that it needs to be above the x-axis, okay? And here, your gradient, because it's a decreasing graph, your gradient is going to be negative. And when it's negative, it means that in the gradient graph, it means that your graph needs to be underneath the x-axis, okay? So we'll look at this at a bit more detail in the next example.